Here's your warm-up for today. It says solve y equals negative x plus 6 when x is the following. So I want to start by plugging 0 in for x. So that'd be y equals 0 plus 6. So y is just going to equal 6. When you plug 1 in, you get negative 1 plus 6, so y is going to equal 5. And when you plug 2 in, y is going to equal 4. So we'll have to do this a little later on today when we start graphing functions. So this is kind of a review, kind of relates it back to what we did first chapter. Any questions on this? We're starting chapter 2 today. Chapter 2 is all about functions. Today is just kind of an introduction to functions, what it means to be a function, and we'll also look at some graphs. There's a couple really important definitions in this chapter. The first one is a function. A function is a relation or a mapping of input values and output values. In the video we were watching, they were just saying how even a soda machine could be considered as a function. The input is the button you press. The output is what it gives you. This is kind of what they were hitting on right at the end. There's only one output value for every input value. So if you're pressing the Coke button, you should expect a Coke to come out. If you press Coke button again, a Coke should come out. Coke button again, Coke should come out. If you hit the Coke button and a Dr. Pepper comes out, that's not a function. So in math world, if we plug 3 in for x, so f of 3 should give us the same output every time. If you're getting a different output, then it's not a function. And that'll make more sense when we look at examples, but for now, this is the definition. Questions on a function? The next definition you need to know is the domain. The domain is also known as the input values, or the x values are the domain. And then this is kind of what we were just talking about with the inputs have to match the outputs. For a relation to be a function, numbers in the domain cannot be repeated. So if we had an xy chart, if I put a 3 in and I get a 5 out, and then I put a 3 in and I get a 7 out, do you see how these are repeating and they have different outputs? That means it is not a function. The y's can repeat, that's just fine, but if the x's repeat, you would say not a function. If it's not a function, you can still call it a relation. That's fine. You just can't use the word function. Any questions on here? So just like domains, all the inputs, range is all the outputs. Outputs you can think of as the y values. And again, I already said this, but here we go. Wrong arrow, I want the big arrow. It doesn't matter if these repeat. So if the range repeats, that's fine. Any questions on what the range is? Alright, here's our first example. So this right here is called a mapping. It's basically just another way to show you what the ordered pairs are. So this is the input, or the x values, and then over here it's the output. So they're saying when you plug negative 1 into your function, you got 5. When you plug negative 3 in, you got 2. When you plug 2 in, you got 0. And then you plugged 1 in and you got 2. Okay, so if you want to write that as xy coordinates, you can. This is just another way to display it. So remember, the domain are the input values. So what are the inputs here? Yeah. These are the input values. We always write them from least to greatest. These braces around here just means it's a set. So the domain is negative 3, negative 1, 1, and 2. What's the range then? Yeah, good. 0, 2, and 5. So there is a repeater here. Is the repeater in the domain or the range? You see how 2 arrows are going to the 2? Yeah. It's okay if the repeater is an output. The repeater cannot be an input. If the repeater is an input, this is not a function. Is this one a function? Yes. Yeah, none of your x's repeat, so this is a function. I'll give you some time to catch up. I know that was a lot of information pretty quickly, but do you guys have any questions? Here's our second example. So again, you can see the inputs and the outputs. The negative 2 goes to 7. When you plug in negative 3, you get 6. When you plug in 5, you get 8. So what is our domain? Very good. The domain is all the inputs written from least to greatest, so -3, -2, 5. What's the range? 6, 7, 8. Are there any repeating values at all? No. So do we have to worry about it? No. Is this a function? Yes. The only thing that would make it not a function is if one of the inputs repeats. So if there's no repeating at all, it's automatically a function. Questions? Here's number 3. So here are my inputs. When you put in -4 to our function, you get 3. When you put in -4 again, you get -1. When you put in 2, you get a 4. When you put in 0, you get a -2. So we'll do domain and range first. What's the domain? Very good. Just your inputs. What's the range? Very good. Now, we have a repeater, right? The repeater makes it not a function because the repeater is one of the inputs. So you put -4 in, you got 3. You put it in again, you got -2. It's kind of like on the soda machine button. If you hit the button and you get 2 different things, there's something wrong with the machine. Here, there's something wrong with this equation or whatever they're plugging this into. It is not a function. Questions? Next, we're going to look at what these graphs look like. I'm sure you guys remember graphing from your Algebra 1 days. Here's a function we're given y equals x minus 4. In the video we watched, they said you could also write this as f of x equals x minus 4. Same thing here if you wanted to write it that way. You definitely could. This is an xy table. I'm sure you've seen these before. These are our input values. After we plug these values in, whatever we get for y will go here, and then we'll graph those ordered pairs. Now, I usually tell students do 3 or 4 points until you can kind of see the trend. In all these examples, they do 5 just to be extra careful. But on your homework, if you want to do 3 points, that's fine. That's enough to see what the function looks like. So what would you get when you plug -2 in here for x? -6. What would you get when you plug -1 in? -5. 0. -4. 1. -3. And 2. Good. So those are all the ordered pairs I'm going to graph. Any question on how I got these values? Is this a function? Yeah, you can tell because none of the x values are repeating and because the directions say graph the function. So. All right, here's a graph. Here are the points. Remember to get to -6, or -2, -6, left 2, down 6, -1, 5, left 1, down 5, side to side 0, down 4, right 1, down 3, right 2, down 2. Anyone need any more explanation on how I got these points? I'm assuming you guys are pretty good at graphing by now. So the first thing you want to do, just to recap, you plug in the x values, that'll give you the y values. Graph each of those points, connect it with a line, arrows on the end. What are your questions? Here's example 5. So y equals -x. So if you put -2 in there for x, what would you get for y? You'd have a -2, which is +2. What about when you plug in a -1? +1. What about when you plug in a 0? 1? -1? 2? -2. Good. It's essentially just switching the signs. Whatever you plug in, y is going to be the opposite of that. So if you plug in a negative, it'll turn positive. Plug in a positive, it'll turn negative. What are your questions on how I got those points? Now we can graph those points. So in your notes, I would just sketch a very quick coordinate plane. I did not bring graph paper today. I'll have some available for you in the future when we graph more. Today's not too crazy graph intensive, just a couple of them, so you can just sketch them. So to graph negative 2, 2, I go left 2, up 2. Negative 1, 1, I go left 1, up 1. 0, 0 is at the origin. Right 1, down 1. Right 2, down 2. And connect it with a line. What are your questions on graphing this function? All right, here's the function y equals negative 3. This is a special case. X equals or y equals always confuse people. It is helpful to look at a table. So no matter what I plug in for x, what is y always going to equal? Negative 3, negative 3, negative 3, negative 3, negative 3. Does anyone remember what this graph looks like? Or if you're unsure, the points might help? Yeah, it's going to be a horizontal line. No matter what you do side to side, you're always going down 3. So it looks like this. Very good. This is a function. If it's x equals something, it's not a function. We'll look at that in a second. We'll learn about something called the vertical line test. But this one is definitely a function. Again, students sometimes struggle graphing these. The table's the easiest way to do it. You can see that all the y values are negative 3. So it's going to be a horizontal line at negative 3. What are your questions? All right, this one just has an extra step. We're going to do it the same way, though. So when we plug in negative 2 for our x value, we'd have negative 2 times 3, which is negative 6. And then you subtract 2 from it. What would you get? Negative 8. When you plug in negative 1, you'd have negative 1 times 3, which is? Minus 2. Negative 5. Good. Once you start to notice the trend, this right here is our slope. It's actually how it affects each of these. You'll notice they're going up by 3 every time. So when you're doing a table, sometimes you can recognize the pattern. It'll help you fill in the rest. If not, just keep plugging in. So if you plug in 0, you get 0 minus 2 is negative 2. When you plug in 1, you get 3 minus 2, that's 1. When you plug in 2, you get 6 minus 2, that's 4. Any questions on how I got those ordered pairs? All right, we can quickly sketch a graph. This one kind of goes off the graph. If you actually just in your notes want to graph these 3 points, that would be completely fine. The other ones are going to kind of go off of our graph here. And connect them. What are your questions? The next thing we're going to look at is called the vertical line test. Anyone remember the vertical line test? It's a really quick way to check if any of your x values are repeating. So here's how you do the vertical line test. If you want to see if a graph is a graph of a function, we use the vertical line test. I know in grade school some people call it a pencil test because you can hold your pencil on the graph, and if the graph touches your pencil in 2 spots, it's not a function. Same thing here. We're going to draw vertical lines on this to double check if something's a function. So if a vertical line is drawn anywhere on the graph and touches at more than 1 point, it is not a function. So we talked about x values repeating makes it not a function. So if you plugged in, let's say 1, and you got 1, you'd end up right here. If you plugged in 1 again and you got 3, you'd end up right here. That would be 2 points right on top of each other. So it would not pass the vertical line test. So the vertical line test is a really simple way just to check if it's a function. So here's just some vertical lines. If you would draw vertical lines on your graph and it would touch your graph in 2 points, any of those vertical lines, it's automatically not a function. Like I said, you might see some people holding a pencil like this. It's an easy way to do it without drawing lines. Usually it's pretty easy to see. Any questions on the vertical line test? So looking at these 2 examples, I'll tell you right away, one of them is going to be a function, one of them is not going to be a function. So to use the vertical line test, you can either just eyeball it or you can draw vertical lines. Touches here once, touches here once, touches here once, touches here once. I cannot draw any vertical line that's going to touch that graph at more than 1 spot. So is that a function? Yes, it passes the vertical line test. All right, let's look at B. If I draw vertical lines through that, you see this vertical line? It touches our function twice. It touches here and here. So I called it a function, but is it really a function? No, it failed the vertical line test. Do you guys see the difference? Any questions? This is the last type of problem we're going to look at. They actually talked about this a lot in the video. This right here is called function notation. You can also see it right here. F of x, it's a kind of just a fancy way to say y. It basically tells you that it is a function. And like they said in the video, if you say f of 0 equals whatever the value is, that gives you a lot more information than saying y equals something. It just tells you the input and the output all at once. So it's kind of nice using function notation. It does take some getting used to. Some students think it's f times 0 or f times x. It's pronounced f of x or f of 0. It basically means you're going to replace all the x's with the value that you see in parentheses. So I'm going to go through and replace all the x's with zeros and then simplify. So f of 0 equals 3 times 0 minus 11. So what is f of 0? Negative 11. There we go. What are your questions on this?
So for your final answer, you have to write f of 0, or can you just write f equals negative 11?
You wouldn't write f equals negative 11. Technically, you could change the f of x back to a y if you wanted. We said these are the y values. If you wanted to say y equals negative 11, you could. I'd prefer you write it just like this. F of 0 equals negative 11. But I will have seen the problem, so I'll know what you plugged in. But yeah, technically this is the proper way to write it. If you just put a box around negative 11, I would know what you meant. What are your questions? Example 11, we want f of x equals x squared minus 4. We want to find f of 1. So what am I going to do? Plug 1 in everywhere you see an x. So my first line would look like this. Now you evaluate it, and again, some people want to do something on the left side here. This is just for notation purposes. There's no math to be done over here. This is just the function evaluated at 1. You don't have to divide both sides by f or divide both sides by 1. This is just strictly notation. The simplifying you're doing is over here on the right. What is 1 squared? 1 minus 4? Good. So f of 1 equals negative 3. I told you we had 12 examples for today, so this is our last one. We're looking at f of x equals 6 minus x, and we want f of negative 5. So how am I going to start this? Very good. Replace all the x's with a negative 5. You all have calculators, but if not, what's minus a negative?
Plus.
Yeah, a plus. So what is f of negative 5? 11. Any questions on this? Alright, here's your homework. I have a new homework sheet for you guys for Chapter 2. Until I hand it out to you, you can just start on these. Again, odd problems, so you can check the answers in the back of the book. I'll give you time at the beginning of class tomorrow. We'll go over any of them that are confusing. You've seen what the homework check look like. They'll look like that in the future, so make sure you're staying organized, keeping up. Any questions?